Alright, welcome back. In this chapter, we're going to talk about structs. Right, as you can see over here, we have this Swift programming language documentation open. It's at docs.swift.org, and we're talking about something called structures and classes. Alright, we're actually not going to spend very much time on classes at all, but they're very similar into structs, and struct is just a short form for structures. I just wanted to open this website so you can take a look at the Swift language documentation, which is where people find out about using Swift as a language. Not necessarily to build apps, but just purely as a language. Okay, so let's scroll up to the beginning and it'll tell you what structs are. Structures and classes are general purpose flexible constructs that become the building blocks of your program's code. You define properties and methods and add functionality to your structures and classes by using the same syntax you use to define constants, variables, and functions. That seems a bit long-winded. Let's go see an example in our code. So I'm going to head back over here and let's go make a new page. If I remember the keyboard shortcut correctly, which I never do, it's Command-Shift-N. Ooh, it's correct. And I'm going to call it structs. Okay, not structure. Right click, rename structs. Ha, got you autocomplete. Okay, so what are structs? Structs are essentially collections of data, right? They're like collections of data. So imagine if you were writing an app about a car, right? So you would want to store many properties of a car, right? So you could do something like var car color equals to blue, okay? You could do var car number of wheels equals to 4. That's a bit silly. I think cars are generally 4 wheels, but that's fine. Right, var car automatic or not equals to true, I think. Right, so something like that. That essentially whether the car is an auto car or a manual car, right? You kind of know what I mean. All right, var car is air conditioned equals to true. Okay, and var car top speed equals to, I don't know, 150 kilometers per hour, mind you, because miles are stupid. And var car num fittable people equals to 5. How many people can fit inside this car? Okay, so that's well and good, right? You now have 6 variables that describe a car. Now, what problem might you run into when you want to create another car? You're going to need to create 6 more variables, right? That's going to be super annoying. Okay, wouldn't it be nice to just lump all these things together into one single type? And in this type, you can define certain properties of a car, such as color, number of wheels, whether it's automatic, whether it's air-conditioned, the top speed, and number of people that can fit inside. I need a better name for this variable, but you get what I mean. So the way we do that is by having something called a struct. Okay, so I'm going to go create a new struct down here. Struct car, open curly brace. And you notice that here, when I type struct car, I use capital C. Okay, and that's on purpose because all your type names are starting with capital letters. Int, bool, double, right? Completely forgot about some of these struct names. All right, these all start with capital letters, and so should any types that you create. So you're creating your own type right now. Well done. Look at how far you've come. You're creating your own types in Swift right now. I'm so proud of you. Okay, so this struct car now has various other types that are stored inside. Okay, so for example, var color colon string. Okay, you don't need to give it an actual value, but you do need to define what type it takes. Okay, so var color colon string. Remember to spell color with a U, right? Don't be a barbarian and spell it without. Next, var number of wheels. That's an integer. Okay, var is automatic. That's right. That's what I should have called it in the first place. Is automatic. Var is air conditioned. Var top speed. That's a double, right? Because maybe it's a decimal number. Var num fittable people inside num fittable people. Right? I still don't have a good name for this. Okay, but this is great. Now I've kind of encapsulated all this data into a struct called a car. Okay, I can delete all these silly variables. And if I want to make a car, right? Not literally. If I want to make a car variable, I could just do this. I could say var, right? My car equals to capital C car. And if I press open bracket, look at this. It's going to create an autocomplete for us that actually asks us to define what each of these properties are. So if I press enter, then I just need to fill in one of these and press tab and keep filling them in, and I'll have a fully fleshed out car. Well, in my code, I will not have a fully fleshed out car in real life. Okay, so let's say this is blue, this is 4, this is true. So I'm just pressing tab to go between each of these, right? True, top speed 150, non-fittable people equals to 5. Right, so that's really nice because it stores everything inside my car. It's just one thing that stores everything. Okay, and if I want to print out properties of my car, I can just say print my car dot is automatic. If I run this, let's open it up on my console. Okay, and it will say true. In fact, you know what? I can print my entire car. I can print my entire car. That doesn't sound right. But what it does is it will print out exactly how I defined it. Okay, it pretty much the same except 150 became 150.0, right? About the same. Okay, so pretty nice, right? Pretty nice. And if you want to make another car, sure. Var another car equals to car, bracket. And this could be a red car with 10 wheels and is a manual and it's not air conditioned, and the top speed is 10 kilometers per hour, but you can fit about 500 people inside. Sure, whatever, right? Go crazy. Okay, so that's how you store all this data into a single variable. Okay, now that's one thing you can do. You can store variables. Now, what else can cars do? They can have functions, right? You might have different functions that a car can run. Okay, so let's go inside here and I'm going to press enter inside the style curly braces, and I could think of functions that a car can execute, right? So what function could we have? I'm just going to write these out as comments, right? So I'm going to make a function called turn, for example, and I'll just write it out in a comment, right? I want a turn function, and maybe I want an accelerate function, and maybe I want a honk function because, you know, that's part of the fun of having a car. Okay, so a turn function could look like this. It could be func turn, okay? And direction colon, I don't know, double, right? Maybe it's an angle bearing or something, right? Okay, and it's going to say print turning to this direction. Okay, so that's simple enough, right? It's just a turn function in a car, and if you give it a certain direction, it will just print out that it's turning to this direction, right? So this is great, right? This is the start of an Apple car right here. So I'm going to try this. I'm going to say my car dot turn direction 50, and I'm going to run this, and let's see what happens in my console, which is buried under this keyboard thing again. So go away and tap on it, turning to 50.0, right? Which doesn't really make sense, but you know, bear with me. Well, I guess there's one thing I want to change in this function. If you remember argument labels, I don't really want to say turn direction 50. I want to say turn to 50. And to support this label, I'm going to have to adjust this function to say turn to direction, right? Remember this very unique Swift thing where Swift can take in an argument label followed by the parameter name. Okay, so the argument label is 2, but within the function body itself, it will refer to it as direction. Okay, so this is perfectly fine. If I run it again, and I'm just going to look at my console. So that's one function, right? That's one function. And this function that lives within a struct is called a method, right? Remember what I said about array methods in the previous chapter? Okay, so anything that you access from within a dot, right? A function that you access from within a dot is pretty much called a method, right? So these functions, they live within structs and they're called methods. These things over here, right, I might have mentioned very briefly, they're called properties. Okay, so this is the turn method, right? So variables that live in structs are called properties. Functions that live in structs are called methods. Okay, so you can imagine what an accelerate function might look like. Func accelerate by amount double, and you'll just say print vroom vroom. Wait, that's not what I typed out. Vroom vroom. All right, there we go. Okay, so that's the general idea behind acceleration. Okay, and over here, if you want a honk function, sure, right? So I'm gonna honk, maybe with a certain loudness. Okay, and you just print honk honk, right? Or if you like me are in Singapore, you could print paw paw, right? Because that's what cars sound like here. I don't know. Okay, so that's the general idea, right? You can create functions. You might want to do something like this, right? Here's something that you might want to do, right? So let's say you want to increase the number of wheels in the car and you want to make a function for that. So here's how it might work. Func increase wheels by, all right, num more wheels int. Okay, and we know that our number of wheels property is called number of wheels right here. So I'm going to copy this, number of wheels plus equals num more wheels. Okay, this seems perfectly fine, right? It's a function and it's trying to change some innate property of the car. However, you get an error. What's the error? If you've seen our SwiftUI video, right, where we talked about state variables, this is the exact same error. It's the one that says self is immutable, right? Self is immutable. So in general, what happens is that these properties should not be changed by functions or methods within the struct itself. Okay, so that's just something to take note of, just a bit of a recollection to what we did in SwiftUI. I'm going to get rid of this, right? You can, however, use these properties, right, to tell the user something else. So for example, right, you might want to tell the user whether this is a really fast car. So here you go. Is this car really fast? Okay, func is fast car. And here's something new, returns a boolean. Okay, let's do this. Let's check if max speed, wait, what's my max speed called? Top speed, not max speed. If top speed is greater than, let's say, 120, that's not that fast, but sure, return true, else return false. Okay, so this is new. There's a bunch of new stuff going on here. This arrow over here, all right, means that this function, when you call it, will end up becoming a Boolean variable. Okay, it'll return you a Boolean variable. So essentially, it's like a little button on your microwave. When you press it, it will spit out a chicken at you. I don't think that's how microwaves work, but that's kind of the idea. Okay, so let me try this out real quick. Right, so I'm going to say if my car dot is fast car. Right, you look carefully at these, right? Two of these are variables and one of this is a function. Okay, so two of these are variables, also known as properties, and one of these is a method, right, or a function. So if my car dot is fast car, then I'll print, woohoo, my car is fast. All right, so let's run this real quick. Take a look. Woohoo, my car is fast. However, the other one is called another car. If another car dot is fast car, let's run it, nothing prints. Okay, nothing prints because it's not a fast car. It took data that belonged within itself and made an evaluation and returned a Boolean into this if statement, which it then used to make a decision on whether to print something or not. I want to go back to this if statement right here. Right? You might have recalled something like this from our previous Swift unit. These are if statements, right? If some condition, then you do something, otherwise return something else. You might also have noticed that this thing over here, top speed greater than 120, is actually a condition that evaluates to true or false. Okay, so if you want to save a bit of typing, and I'm all about saving typing as you know, right? You can actually delete all this and just say return top speed greater than 120. Okay, you can actually return top speed greater than 120 because this thing if this little chunk of code evaluates to true, it'll return true. If it evaluates to false, it'll return false. Okay, and return just means give back something to the person calling this function, right? Sometimes there are functions that don't return anything, right? But in this case, there is. So let's run the code one more time. Over here, another car is not a fast car, so it doesn't print anything, but my car is a fast car, and it does print, woohoo, my car is fast. I want to point out one more little optimization. I'm very sorry. I like to remove code and keep things nice and short. This thing over here, if your return is the only line inside your function, you can actually get rid of the word return. So you can do this. Okay, so it reads quite simply. It just says, is fast car returns a boolean, right? And it just evaluates this line. If it's true, it returns true. If it's false, it returns false. Okay, and that's it, right? That's it for our little introduction to structs. Okay, so what I'd like you to do now in the exercise is to add a method to describe your car. Okay, right now, if I print the car, it just prints out this little chunk of code, right? Which is not very interesting, right? I would like you to have a method, and maybe it's easier if I type it up, right? So I'd like you to have a method called describe. So mycar.describe, okay? It currently doesn't exist, so there's an error, okay? When this code is run, I'd like this to print out, this car is blue in color, has 4 wheels, is automatic, is air conditioned, has a top speed of 150.0, and fits 5 people. Okay, so it should print out this line in the console when you run a function called .describe. Okay, so that's my first little exercise for you. Please pause the video and give it a try.